of last semester, ODL. Okay. Wait. Okay, so this one, it is a perfectly mixed. It's already mentioned there. It is a perfectly mixed tank. So you should not use that as your assumption because it's already mentioned there. Okay, now you are mentioned here 0.9 kilomole of sodium bicarbonate being dissolved in 100 kilogram of water. Okay, when the dissolution is complete and the time is started, pure water is fed to the tank. So if I can draw a figure, I have pure water here. I have solution here coming out of the tank. So here I already have, before the time start, I already have 0.9 kilomole of Na2CO3 plus 100 water, alcohol water. Okay, and the flow of the pure water is F dot, while the outlet is half of the input. So this one is half of the input. Okay, so generally the drawingnya is this way lah. Let me see whether I give the drawing marks or not. It's not given. Yes, it's not given any marks because it's not required in the question for you to draw. So no need to draw. But if you want to draw to have a look on to have an idea of the question, then please draw. Okay. Now, write differential equations for total mass and sodium carbonate. Provide initial conditions and list your assumption. So if you go to the statement here, list your assumption, it's only one assumption. Okay, please don't list many assumptions. It's only one. Any that you can think of the assumption. Okay, there may be many assumptions, but only one is required. Okay, now write differential equation. So if we can start, we start from the general equation. Input minus output. So if I want to put generation minus consumption, then if I cross this, because I neglect this one, so I can say non-reactive. So this can be one of my assumption and not really assumption, but you can use as assumption. So this assumption, if you put into the list of the assumption required by the question, I would say out of one, I give you half lah, because it's not really the assumption. It's not really the assumption. Okay, so you have input minus output. So dm over dt, m dot in, this is the general equation. Dm over dt is m dot in minus m dot out. So dm over dt is m is your mass. So I think we should not replace that with any other variable, the m. Okay, but m in is actually f dot, right? The one given in the question. And the outlet is half f dot. So it is half f dot. Yeah. So your dm dt is half f dot. Okay, as simple as that. All right. So now T0. What will be your m? T0, what will be your m? Anybody can help me with that? Anybody? Tutorial should be a two-way communications. So, anybody who want to try? What is m initially?
100 kilogram of water plus the conversion of 0.5 9 kilomole of sodium carbonate to the
Yes,
kilogram.
yes, exactly, Lydia. That's the answer. So your M is actually because as mentioned in the question, before you start, the water and the sodium carbonate actually being dissolved, already being dissolved in the tank. So before you start the time, the sodium carbonate and the water is already there. So it is 100 kilogram of water plus 0.9 kilomole of that Na2CO3. So you should not left the answer this way because it's not consistent with the unit. So you need to change or convert the unit. 0.9 kilomole multiply with this molecular weight 105.99. Is that so? Yes. So you should get 195.4 kilogram. So this is supposed to be the mass in the tank before you start the time. Okay? Okay, clear on that on the total mass. Any question? Any question on this? No. So next is on the sodium carbonate. The sodium carbonate. Uh, the first one is total mass. This one is on component balance. Okay, component balance. So you have accumulation, input minus output, plus generation minus consumption. So again, this one is neglected because non-reactive. All right, so now input accumulation dm over dt, m dot in minus m dot out. Now, what is our m? How we want to change the m so that it can represent the sodium carbonate. How are we going to change the m so that it can represent the sodium carbonate? Can I just as simple as put d, or can I just m equal to m sodium carbonate? Can I do this? M is equal to m sodium carbonate. Can I do this? Anybody? Boleh ke? I just replace the m with m and natrium bicarbonate. Now I want to have, the relation must have something to do with the sodium carbonate. If I refer to the question, if you go to B, do you have any clue? Do you have any clue looking to B? Basically, in your textbook, it's all volume concentration. But this question is totally different than the one we discussed, and totally different from the one in the textbook, the sample, the example. Okay, but in the problem, if you go to the problem, this is actually one of the problem question that I modified. Okay, so now untuk component balance, how are you going to represent the M so that it is actually related to your sodium bicarbonate? You get my question or not? Tak ada. Ini ni kena call name ni baru jadi ni. Okay. I'm not that kind of calling names. Okay, tak ada nak jawab M equal to M. Can saya tanya ni, can I replace the M with M natrium carbonate? Itu je soalan saya. Yes or no? Yes or no? Imran kata no, doktor. Okay. So Imran, if no, then any clue? So cannot, this one cannot. Because if you replace M with M natrium carbonate, natrium bicarbonate, how are you going to see the change of the sodium bicarbonate in the tank with respect to time? Okay, because M already been used initially for the total mass. So the MBT, we know that this change is actually in the tank, in the tank, the change in the tank with respect to time. So now I want to see the change of the sodium bicarbonate in the tank. If I just put M here, that M actually, there is no specific, it's not to say no specific. If you use M, so M to represent the total mass. So you need to do something, or you need to multiply with something so that M can be represented or can be related to the ni. So sekarang kita nak cari this one actually, MNA2CO3. MNA2CO3. So if I go to question B, any idea as I say? Any idea, any clue from B? What is actually being used to represent the sodium bicarbonate?
The mass fraction of
yes, Nidia.
sodium.
Mass fraction, Nidia. Okay, I'm hoping Nidia to get A lah for my subject because you are, good enough in understanding the question. So it is actually X. So if I multiply X with M, where X is my mass fraction of Na2CO3. Okay, so this one, if mass fraction multiply with the total mass in the tank, it will give you the mass of the natrium or sodium bicarbonate. Okay, so you should replace your M here with X dm. Okay, so it should be dxm over dt. Your M dot in. Do you have any flow of the sodium bicarbonate in the feed? 0. Because as mentioned in the question, you feed pure water being fed to the tank. So you feed pure water, no sodium bicarbonate being fed to the tank. So it's 0. Your output, if you put half F dot, this is the solution, the flow of the solution. If I just want to know the flow of the sodium bicarbonate, I multiply with X. Okay? If I multiply the fraction with the total flow, I get the flow of that component. Okay, if I can just draw you, let's say I have here, coming out here, I have 0.6, 0.4 water, 0.6 sodium carbonate, and yes, sodium carbonate. So I flow here is 100. So let's say this 100 is half of that F dot. So if I know the fraction of the sodium bicarbonate, which is 0.6, so this is actually the flow of my sodium bicarbonate alone, not the total flow of the solution. Okay, you get me or not? Hope you get me. All right. So now, I need to add another slide. Okay. So now looking to the one we derived, D xm over dt, it is 0 minus half of f dot x. Okay, so this one, should we need to expand it? We have to think of whether your fraction change with time, your m change with time. This one. The previous example is dVCA. Volume change with time, CA change with time. So you got V dCA over dt plus CA dV over dt, because both change with time. So you have both. So if you expand this expression, it will be this way. So this one, I ask you, the mass fraction change or not, or mass change or not? Both change or only one change? Both change. Okay?
Both
So
change.
both change. Betul. Thank you. Who answering that? Saya tak boleh tengok lah. Saya tak tahu siapa. Thank you for answering me. So both change. So when both change, so you have x dm dt plus m dx dt. So this is the expression that we are looking for the component balance, dx over dt, because this actually represent the sodium bicarbonate, equal to negative half x f dot. Okay, so dm dt, if you refer to dm dt of your total balance, previously this one, okay, not this one, half f dot. So your dm dt is half f dot. Okay, and plus your m dx dt plus negative half x f dot. So you can simplify that, dx dt minus x f dot, and dx dt is actually minus x f dot over m. Okay, so this m you should integrate to get the m. You should integrate to get the m. Okay, please don't just leave the m there. In fact, actually, if you want to solve this the b, if you want to solve b, actually you need to integrate that. So up to you whether you want to integrate in a or you want to integrate in b. Up to you lah, the m. Okay, I will give you mark accordingly. But so it is supposed to be integrated in the first in a. Okay. So if I integrate that, dm is 195.4 to m. What is the relation tadi? Half f dot. Okay. Half f dot. Half f dot dt. So you can take the f because s is the flow. F is the flow. You have to assume the flow, where the flow is a constant. It can be 100 kg per minute. It can be 200 kg per minute. You can refer to B because you are required to assume 3 flow. So F is a constant. So no need to integrate. It's a constant. So you take it out. So here you got M minus 195.4 equal to half F dot T. So you simplify M 195.4 plus half F dot T. So you replace that here. Okay. Now, it's done on the component balance. Now, T0. What is your X? T0. What is your mass fraction? At time equal to 0, before you start the time, what is the mass fraction of your sodium bicarbonate in the tank? So refer to the dissolution process earlier, 0.9 kilomole of natrium bicarbonate or sodium bicarbonate over 100 kilogram of water. Okay, mass of your component divide by, wait, it's supposed to be divide by total mass, right? To get the fraction. The fraction is mass of component divided by total mass. So I guess you should add here mass fraction then. Mass is over total, right? So this one plus 0.9 kilomole. So what will be the composition or the fraction bagi 100 campur sampai 9. So it is 0.49. Kalau kita just divide by water, it is the R kan? Bukan R juga. So X is, if I can write it here, X is the fraction, So mass of the sodium bicarbonate, which is 0.9 kilomole, divide by 0.9 kilomole plus 100 kilogram of water, right? So from here you've got 0.49. Okay, 0.49. Okay, so you got 0.49. That is at T0. So your fraction at T0 is 0.49. Okay, and then to solve B, you need to integrate. So to solve B, because you are required to integrate differential equation of Na2CO3 and generate the plots of mass fraction of Na2CO3 versus time. Okay. So you have to integrate that dx over dt equal to minus xf dot over 195.4 plus half f dot t. So to do the integration, you have dx here, negative 1 over fx. F you can take it out because as I mentioned, it is actually a constant. And here you integrate dt from 0 to t, 195.4 plus half f dot t. Okay, so if you do the integration, you show lah how you integrate. Okay, wait. Yes, you should get, I just give you the final answer, the rest you should try by your own. 0.49, 0. Wait. 0.0026 Tf dot plus 1 to the power of negative 2. Okay, so this is the relation of the after you integrate the component balance, you got this. So mass fraction with respect to time, the change. Okay, then you assume your F, because this is ODL, open distance learning, and open question, so you can choose any of your F. So if I see any of you giving the same 3F, so it means that you discuss among you lah. Okay, so we will report that as plagiarism. So that's why, because the F, no range given for the F. So if I want to say F 1 kilogram per minute, up to you. If I want to say my second F is 1000 kilogram per minute, up to you, because it's no restriction in selecting the F. Okay. All right. So for my case, I choose 100, 200, 300. So I should get a different value. There's some error with the value here, but I noticed that the fraction keep reducing with respect to time. So when you replace with 100, so you put it here, then okay. Saya, for my example, I use T. I fix the T. I said T is 5 minute. 5 minute go. 5 minute. My F is 100. So I put it here. So I got X. If I maintain at 5 minute, F is 200. Changing the F only. So I notice that the pattern, it will be this way. Okay. Kind of this. X versus T. You can use Excel actually, because this is ODL and open. You can use your Excel. Okay, because last time when I marked this question, some student, the answer is this way. The pattern is there. It's reducing with respect to your flow, but it's a straight line. I don't think this is a straight line. Okay, I don't think this is a straight line. Okay, unless you memang totally wrong with your integration lah. Okay, that's why you dapat straight line. All right, so that one is for the first question. Any uncertainties or any question to ask?
Betul.
Yes.
Kalau tadi cakap pasal Excel ni, maksudnya kalau hantar dengan template Excel pun boleh ke maksudnya?
You copy lah, because dia nak plot je kan? Dia nak plot. So from your Excel tu, you dapat dah dia punya figure kan? So you copy the figure, paste in your solution, in your answer punya booklet lah.
Okay.
Just paste in that. Tapi don't worry, I accept that. Memang I terima Excel tu. Don't please, it's a 24 hours question, so you are allowed to do so. Discuss je tak boleh. Okay.
Hantar template sekali boleh tak?
Apa dia?
Template Excel sekali. Hantar sekali.
Boleh nak hantar, boleh. Tapi normally for final assessment, kita kan allow you only to submit one kan? One document.
In PDF kan?
You copy within your, that's why I kata you copy within your solution answer scheme you all tu, atau kertas you all lah, and then you convert to PDF, submit together with the ni. Okay? Alright. So the complete answer for this you should try lah. But you already, now I gave you the relation X with respect to T, so you should be able to have to solve this lah. Okay, and then for the plotting, if you do in Excel, there is already a scale, so it's very good to have that. Okay, if you plot or sketch, so you have to put something lah here. Let's say this is 5 minute, because as we stated at 5 minutes, so this is F of what? F of 100, 200, 300. Okay, all right. So now we go to the second question. So now the second question is actually as what we basically discussed in our lecture. It's about concentration, it's about volume. Okay, so this is the general one. The earlier one is not that too general lah. Okay, you have to sort of do something. Okay, represent. So for the first question tadi, the correct assumption for me is this one. Okay, the correct assumption is this one, X, where X is my mass fraction of the sodium bicarbonate. All right. Okay, so for this one, um, you have sodium chloride solution enters at 4 meter cube per minute, leaving the tank at 3 meter cube per minute. The capacity of the tank is 500 meter cube, and the tank is initially half filled with water. Half filled with water. Okay, so if it is 500, then in the tank you already have a volume of 250 meter cube. So basically this is the drawing lah. Your inlet is 4 meter cube per minute, your outlet is 3 meter cube per minute, your sodium is 50 kilogram per meter cube. So for the total mass, the general equation, so this is what we basically discussed again and again. So the inlet is 4 with times the density, outlet is 3 times density, then simplify, you got dVdt equal to 1. T0, your volume is 250 meter cube. Okay. So for the component balance, this is very straightforward. Okay, so this one I think is okay. So accumulation equal to input output. So your M is CAV. So CAV, you expand it this way. So your inlets for CA in, your output is 3 CA out, where your CA and CA out, CA here and CA out here is the same because perfectly mixed. So you expand this, you got this one. Okay, so write the volume with time and concentration with time. So in A, you need to already integrate. So you have to integrate. You have to integrate your V. This is your V. dVdt. You got 250 plus T. And then you put this V here. And then integrate the dCA over dt. So you got this one. Okay, your CA is 50, simplify lah, simplify. So if you just left it here, then you cannot get full marks lah, because basically if you look into this one, it's not a simplification kind of presentation. Okay, so kita nak yang lebih simple, yang lebih dah simplify lah, dah simplify. Okay, so you got this. Okay, so next. This is V with respect to T. This is CA with respect to T. Now, if you go to the question, dia kata after 60 minutes is 310. Proof that after 60 minutes of the operation, your tank is already 310. So we put into this one. Okay, when you have T of 60, you got 310 meter cube lah. Betul lah. And then the time taken, show that the additional time taken for the tank to be fully filled with the solution is around 107 minutes. Okay. So from 250, after 60 minutes, dia dah jadi 310 meter cube. So to fill another 190, which is the balance, and the total is 500. Now after 60 minutes, already filled with 310. So the balance is 190 meter cube. So just use a relation because now your outlet ni close. So you only inlet 4 meter cube per minute being fed. So every 1 minute 4 meter cube being fed. So if 190 meter cube, how long you need the time? 47.5. So the 107 is actually 60 plus 47.5 minutes. So you got 107.5 minutes, which is actually around 107 as given in the question tu. So from 250 ni, nak penuh sampai 500, 60 tadi, 60 minit tadi, dia go up to 310. At 60 minit tu, you require 60 minutes to fill up to 310 because you still have you have the inlet and your outlet is there. You have both inlet outlet. That's why you only require 60 minutes. Here, 3 minutes, 3 meter cube per minute. So the range or the difference is 1 meter cube per minute. So that's why you need longer time, 60 minutes. But from 310 to 500, you close this one. So you have shorter time lah to fill in up to 500 because it's 4 meter cube per minute being fed. Okay, tadi 4 meter cube, outnya 3 meter cube. So only 1 meter cube being filled here. But now for the second process, they dah close the output. So you only require 47.5. So the total time to add is 107 minutes. Clear?
Clear, doctor.
All right. So I think if clear, then that's all for me. Any question? Any other question? If no question, then that's all for me. Thank you very much. See you next week. All right. Yeah, Azhar. Okay. Jumpa lagi minggu depan eh.
Thank you, doctor.
Thank you. Thank you.
Thank you, Doctor.